Howdy folks, Mr. Z here. We're going to continue our work on trigonometry today and looking at the unit circle. The unit circle, as we've talked about, is a circle put on a coordinate plane with a center at 0, 0 and a radius of 1, hence the term unit circle. One thing that we mentioned yesterday when we talked about the unit circle is a new variable that we call theta. It's spelled like this. Theta represents an angular variable, which means that we can actually measure an angle rotating around the circle. It's important to note that with theta, as a typical convention in math, our starting position is actually this angle right here, extending from the origin to 1, 0, hence the label 0. As theta increases, it rotates counterclockwise around the circle. Conversely, theta decreasing in a negative direction would rotate clockwise around the circle. One thing that we talked about is how the values of the x and y coordinates along the circumference of the circle changes as theta increases. We mentioned that there's two elements. There's the x element, which measures the up and down value as theta rotates around. What is the value along the x-axis if we dropped down the value to the x-axis? We labeled that for further discussion as the cosine function. Alternatively, the y position, if we were to drop any angle down to the y-axis, then we would get our sine function. The rationale of today's lesson is actually looking forward into trigonometry, past the unit circle, into understanding how we can use the unit circle to inform our understanding of trigonometric functions. Today, we will be focusing our attention on cosine and sine functions. As this lovely diagram indicates, here we have our unit circle, okay? And along this unit circle, we have attached a x-coordinate, basically tracker, which ties to this cosine function. And over here, we have a y-position tracker for our sine function. As I will demonstrate in the next several slides, please watch as theta increases in a counterclockwise position, and how do these functions also change. Here we see our first position. Sine elevates, cosine from its peak over here starts to decrease, and so we see that same pattern until we get to the x of our unit circle. Here, sine seems to peak at 1, and cosine manages to hit that 0, which makes sense since the coordinate pair for theta when it is equal to pi over 2 is 0, 1, aka our cosine or x value is 0 and our sine value or y value is 1. As we continue along, we can see the progress as theta increases. Eventually, it will come back to where it started. Here, where it starts at 0, or alternatively 2 pi, we see a full period of both the sine and the cosine function. Notice that right where it ends is also where it begins. The same is true for sine. Starts at 0, goes up to 1, drops back to 0, down to -1, before returning back to 0 in an upward trend. And that's it, folks. We will be working on exercises using a mini-unit circle diagram to reinforce what we just learned.